In this video, we're just going to review domain and range of a function. So remember, a function is the set of ordered pairs in which each input has exactly one output. The domain are the valid, real numbers that output real numbers. Okay, remember your domain is your input. Guess we don't really need to say valid. It's a set of real numbers that you are allowed to plug in that will output a real number. And the range is the set of real numbers that you output that are based on what you plug in. And just a refresher, function notation, you usually give it a name by a lowercase letter, and most common is f of x. So f of x is referencing that what you have is a function, f of x, because f is defined by what you plug in for x. So the next thing to go over is a special type of function called a one-to-one function. I'm bringing up one-to-one function because that is important when we talk about inverse functions. A function is one-to-one if each input has a unique output. So for example, we'll do not one-to-one, and then we will do one that is one-to-one. So not one-to-one, an example of this would be y equals x squared. If I made a quick table of values, if I plug in -2, I get 4. If I plug in -1, I get 1. 0, I get 0. 1, I get 1. 2, I get 4. This is not a one-to-one function because each input does not have a unique output. -2 and 2 share the same output, so this is not one-to-one. So what this means is, if I was to graph this, if I'm not one-to-one, okay, what that means is there are two different x's that are going to produce the same y value. So that means that I am not going to pass what we call the horizontal line test. And what that's actually checking for is the function one-to-one. What that means, if you remember from Algebra 2, if a function does not pass the horizontal line test, that means that the inverse is not a function. Remember, inverse would be, if we flip to the table of values, our input would be 4, and it would give us an output of -2 and 2. So what you have to do when we review inverse functions, we have to take away part of the domain so that it does pass the horizontal line test. Okay, and so an example of a one-to-one function would be something like y equals x plus 2. If I make a table of values, -2 plus 2 is 0. 1, 2, 3, 4. I can see I'm just going to keep decreasing in value, increasing in value. I will never have an output that is shared by two different inputs. And how can you check if it's one-to-one? You have to make sure you pass the horizontal line test. So now let's go over having a graph, making sure that we can state the domain and the range. The domain, valid input, range, valid output. So the domain here, what we are checking for is where there is a chunk of the graph for every x. So we can see that x runs horizontally, so we want to check, okay, the graph starts here and then goes to the right infinitely, which means it's picking up everything that's greater than 2. But since it's an open circle, when x is 2, that means we are not defined at 2, but we can get infinitely close to 2 from the right side of the value x is 2. So the domain would be x is greater than 2. Now, if we use interval notation, okay, the same way of writing x is greater than 2, we would write it starts at 2 and it goes to infinity. Now, you always have some brackets that are going to go around the start to the end when you use interval notation. Around infinity, negative infinity, you always use a parenthesis. Now, if 2 is included, you would put a square parenthesis. If 2 is not included, you would put just a regular parenthesis. So, this right here is just the interval notation of saying x is greater than 2. So this means the same thing as that. So now let's look at our range. Our range is our y values. So our y values go vertically. So we check the smallest value we have here, 3, but we're not defined at 3. And then we go, this graph is everything up from 3 infinitely. So the range would be y is greater than 3. So if we wrote this interval notation, 3, infinity. So the next thing we're going to do is state the domain and range of each of these functions. So number 1, number 2, number 3, number 4, we don't have the graphs. As long as you can identify what type of function you have, you might not necessarily have to look at the graph. You could keep that in mind, but after studying Algebra 2, you should be able to know about domain and range based on what type of function you have. So in number 1, we have y equals 2x plus 1. This is a linear function, okay? It's got a slope of 2, so we know it does have a slope, so it's going to look something like this, the graph, right? So we know that the domain, okay, domain x goes all the way to the left, all the way to the right. Can you think of, and if you want to just do this without thinking of the graph, okay, is there any real number that if you plug it in will not output a real number? Okay, so every real number that I plug in, I'm going to multiply it by 2 and I'm going to add 1. So it's going to give me a real number. That means the domain is the set of all real numbers. That means from negative infinity to infinity. So that would be the interval notation of just saying all real numbers. If you think of the range, okay, you plug in all real numbers, you multiply them by 2, you add 1, you're going to get all real numbers. You could see that by the graph. It goes all the way down, all the way up, no gaps. Okay, when you have a line, the only time your range will not be all real numbers is if you had a horizontal line like y equals 4. Number 2, if you identify what type of function you have, it's going to help you understand the domain and the range. So this is a quadratic function. So we've studied quadratic functions long enough to know about the domain and range of a quadratic. Is there any real number that if you plug it in, 4y equals x squared minus 5x plus 1, you would ever output something that's not real? No, so the domain here is all real. Now, if you think about the graph of a quadratic, it's either going to look like this or it's going to look like this. All depends on what a is. This is in standard form. A is 1, so the graph is going to look like this. So we know our range, we're going to have a minimum value. So we have to figure that. That minimum value is coming from the vertex. So I have to do some work to get the x-coordinate of the vertex, right? So that's negative 5 over 2 times 1. That's 5 halves. So the minimum value is going to occur when x is 5 halves. So now we have to get the minimum value. And that's going to give us 25 over 4 minus 25 over 2 plus 1. 25 over 4 minus 50 over 4 plus 4 over 4. That's going to give us negative 25 fourths plus 4 fourths. That's going to give us negative 21 fourths. So our domain, this is going to be the minimum value. So our domain is all real numbers, okay? And our range, okay, that's the lowest value it can be, and then it's everything above that. So y is greater than or equal to negative 21 fourths. Now if we write this as interval notation, that's going to be the smallest number first, so negative 21 fourths. And look, I put a square bracket there. That's because we include negative 21 fourths, comma, and it goes to infinity. Number three is y equals square root of negative x plus 2. This is a square root function. Square root functions have restricted domains because there are some real numbers that if we plug them in are going to make outputs that are not real, and that is because we cannot take the square root of a negative number. So when we are concerned with identifying the domain of any square root function, we need to make sure that the radicand, which is negative x plus 2, whenever you have a square root, has to be greater than or equal to 0. So now, if we solve this inequality here, we will be able to find the set of real numbers that is the domain. So, take away 2 from both sides, divide by negative 1, and we get x is, we have to flip this symbol, we just divided by a negative, x is less than or equal to 2. So that's the domain, x is less than or equal to 2. If we wrote that in interval notation, now x is less than or equal to 2. 2 is the biggest value we could be. The smallest value we could be is negative infinity. Now, the domain starts when x is 2. If you plug in 2, if we determine our range, okay, if we plug in the start, we get negative 2 plus 2, we get 0. So the first output that we're going to get is 0. Now, we're going to plug numbers in, and we're going to take the square root. The first number is 0. Let's pick another number, 1. The square root of negative 1 plus 2, square root of 1, that's 1. If you think about this, we're going to take the square root of a value we know is going to be, it's going to be a real number. And when you take the square root of any value, it can't be negative. Therefore, the range here is y is greater than or equal to 0. And number 4, identify what type it is. This is a cubed root function. Can you take the cubed root of a negative number? Yes. Can you take the cubed root of a positive number? Yes. Can you take the cubed root of 0? Yes. Therefore, x can be a negative number, can be 0, can be positive, and it will output all real numbers. So your domain is all real numbers. And your range, if you input negative numbers and you take the cubed root, you're going to get all negative numbers. If you input 0, you're going to take the cubed root, you're going to get 0. If you plug in all positive numbers, you're going to take the cubed root, you're going to get all positive numbers. The range, if it's just a cubed root, will always be all real numbers. So that's it for a review of domain and range of a function.